Hello, welcome to EcademicTube. Here on this platform, we are going to help you in online project report, online lab reports, assignment guides, live sessions, and video solutions. To contact us, you can reach to us through our WhatsApp number or through our mail ID, that is projects@academictube.com. So let's move to our question on strength of material. So this is a question of strength of material, and the question says that here it is an aluminum bar which have two cross sections from A to B and from B to C. From B to C, you can see this is a rectangular uniform cross section, but from A to B, you can see that it is a varying cross section. Okay, and we have this HX also, which is 2 minus 0.2 x, and the elastic property of this beam, that is of aluminum, given to us is we have elastic modulus, that is 10,000 ksi, and Poisson's ratio, that is 0.25. This load P is also given to us, that is 10 kips. The thickness of this cross section, is uniform throughout the length of the beam, that is 3 by 4 of inch, or we can say 0.75 inch. Now what we have to calculate is total elongation of the wire under shown uniaxial loading. Okay, this is our loading, so we have to calculate the total elongation of this wire from A to B plus from B to C. Then we have to calculate the change in dimension in BC section. This is BC section or of the bar in bi-direction. Okay, so we have to calculate the change in direction, whatever be the elongation or compression into BC section. We have to calculate that change. Okay, so keep remember that we have to calculate the vertical change in BC member. Okay, don't blindly go to calculate the horizontal BC change. Now let's move to our solution part. Okay, so first what we will do is we know that a few things. We know the data, that is we know this p value, and this is p value. Okay, we know this elastic modulus also, you know this Poisson's ratio, this hx. Okay, so we know these following things. Let's calculate the area of this cross section BC. This is the area of cross section BC. What will be the area of this cross section BC? Let's calculate. This area of BC will be this depth into this height. Okay, this height you can see 2 inch, and this is uniform throughout the length. This is 3 by 4 of inch. So I can write 3 by 4 multiply by 2, which will become as 3 by 2. Okay, that is 1.5 inch square. This is the area of cross section of BC. Let's calculate the area of cross section of AB also. So for this is the height which is varying in hx. So we will, and this hx is half of this AB. Okay, so this is hx, and this is one more hx, so twice of hx. Twice of hx multiply by this depth. This is 3 by 4. So we can write 2 multiply by 2 minus 0.02 x multiply by 3 by 4. So it will come as area of cross section of AB will be 3 minus 0.03 inch square. Okay, so we have just write the area of cross section of AB and BC. Now for A part, we have to calculate the total elongation of the bar. So for total elongation, delta CA is equal to delta CB plus delta BA. So this is the total elongation of the bar. For this, let's calculate the total elongation in BA section. No. First, we will calculate the total elongation in BC section. So for BC, we can directly write. For BC, we can directly write PL divided by AE. PL divided by AE. This is for BC section. So this load given to us 10 multiplied by length is 20 inch divided by area we have already calculated, that is 1.5 multiplied by 10,000. So this calculation will become as 0.0133. Okay, this is in inch. Now we will move towards deflection calculation in BA. So this is the varying cross section, and for any varying cross section we use the integration. Okay, so using integration we can write P, now it will be write dx, P dx AE, that is area of AB cross section which we have calculated. That area of cross section of AB and E. And further we can write, let's see the figure first. This is varying from x, this x is in horizontal direction, you can see this x is in horizontal direction, so the limit will be 0 to 50. Okay, so the limit will be 0 to 50, 0 to 50, and the load is P dx divided by area is 3 minus 0.03 x, and this 10,000. Okay, so this will be 10 to the power minus 3, and this 1 upon 3 minus 0.3x. This will be logarithmic of 3 minus 0.03x. Okay, and the limit will be from 0 to 50 divided by minus 0.03. So by calculating this whole term, we can write that the deflection in a BA cross section will be 0.2308. This will be come after solving this whole term. Okay. So further we can write BCA is equal to BCB plus delta B. This is BA. So this is CB is 0.0.0133 plus 0.2308. So after calculating, we will get the total deflection in the beam is 0.03638 inch. Okay. So this is our final answer for total deflection in beam from A to C. Now for the B part, remember what it says, that we have to calculate the vertical change in this BC member, vertical change in this BC member. So we are going to use the Poisson's ratio. What Poisson's ratio says, that the strain in the y direction will be is equal to minus times of Poisson's ratio of strain in the x direction. So what we can say, the strain in y direction for BC member. So for BC member, I am talking about only BC member. So delta y divided by y is equal to minus nu delta x divided by x. Okay. So for delta y we have to calculate this. Okay. What we have to calculate is delta y, change in y direction. So we can write delta y divided by y. What is the y here? Y is 2 and this x is 20, and delta x is, or yes, delta x is a change in CV, that is this 0.0133. So let's say 2 is equal to minus 0. What is the position? 0.25 multiply by delta is 0.0133 divided by 20. So delta y will be minus times of 0.0003325 inch. This is the delta y, the change in y direction for BC section. Now the point is, why negative sign? What negative sign indicates? Negative sign indicates the decrease in the length in y direction. Okay, decrease in the length in y direction. So when applying this load, when applying this load P here, when applying this load P here, this BC length will get elongate. This BC length in x direction gets elongate, but in y direction this BC will contract. Okay, this BC will contract. This is 2 inch. So after elongation, this 2 inch will be this 2 inch, the vertical height of BC will be less than 2 inch. So it will be like 2 minus 0.0003325. This will be the final vertical height of BC member. So negative sign shows that decrease in the BC vertical height. So this is all. I hope you got clear.